Okay, so picture this with me. A moon. But not just any moon. We're talking about a moon covered in ice. And get this, under that ice, there's an ocean. And not just any ocean, right? This ocean might, just might, hold the key to life beyond Earth.
It's incredible to think about.
It really is. And that's what we're diving into today. Jupiter's moon, Europa.
Europa. Yeah, it's got scientists buzzing, and for good reason.
We're talking about a moon with more water than all of Earth's oceans combined. It's like something out of science fiction. But it's real, and it's out there. And this month, NASA's launching a mission to explore this icy world, the Europa Clipper.
That's right, the Europa Clipper. And it's a mission decades in the making. I mean, this spacecraft is massive. Imagine this, a spacecraft longer than a basketball court. Longer, with these huge solar panels stretching out like giant wings. That's Europa Clipper.
Wow, a basketball court in space. So we've got this incredible spacecraft and a potentially habitable ocean moon, but why Europa? Why all this effort for this one icy moon? What makes it so special in our search for life beyond Earth?
Well, on Earth, wherever we find liquid water, we tend to find life, right? And Europa's ocean, it isn't just some tiny puddle. This is vast. It's a vast, potentially life-supporting environment.
So what are we talking about here? Like alien whales singing under the ice? What kind of life could even survive in such a dark, cold place?
That's the million-dollar question. It could be microbial life, something similar to those extremophiles we find here on Earth, thriving in those really extreme environments.
Yeah.
Or it could be something completely different, something we haven't even imagined.
Okay, now we're getting to the really exciting part. We've got this spacecraft, a potentially habitable ocean moon.
Mm-hmm.
But how do we even get there? It's not like hopping on a rocket and taking a straight shot, is it?
Definitely not. It's more like a cosmic ballet, really. A carefully choreographed dance across the solar system. We're talking about a 6-year journey.
6 years.
6 years to reach Jupiter. And to get there, we're actually using the gravity of other planets.
Wait, are you serious? We're using planets as slingshots? Is that even a real thing?
It is. It's a real thing. It's called a gravity assist. Essentially, the spacecraft swings past Mars, and it kind of steals a bit of Mars momentum, using that gravity to speed up. Like a cosmic slingshot. It's pretty clever.
That's insanely cool. Okay, so 6 years, a cosmic slingshot maneuver. Sounds like a long haul. What happens when Europa Clipper finally arrives at Jupiter in 2030? Do we try to land on this icy moon?
Landing on Europa is risky, very risky. Jupiter emits this intense radiation. So, landing on the surface, that has the potential to fry sensitive electronics. Imagine a giant cosmic microwave. Not exactly ideal for delicate scientific instruments.
Yikes. So what's the plan then? How do we study Europa if we can't even land on it?
That's where things get even more interesting. Instead of landing, Europa Clipper will perform almost 50 close flybys over 3 years.
50 flybys?
Yep, 50. It's designed to minimize the radiation exposure, but maximize the amount of data we're collecting. So think of it as a series of very carefully planned glimpses into this alien world.
50 flybys. Okay, so we're not just dipping our toes in the water here. We're going for a full-on swim. But how do we even gather data from so far away?
Well, Europa Clipper is equipped with 9 state-of-the-art instruments, each designed to unlock Europa's secrets. And these aren't your everyday telescopes and cameras. We're talking seriously high-tech equipment. I mean, these instruments are so sensitive, they could spot a plume of water vapor erupting from the ocean below, even from space.
Hold on, water vapor. You're telling me there's a chance we could get a glimpse of what's actually in that hidden ocean without ever touching down?
Precisely. If we can capture those plumes, analyze their composition, who knows what we might find? It's like getting a sneak peek right into the heart of Europa's ocean.
Okay, so we're talking about analyzing alien ocean spray from millions of miles away. That's incredible. Tell me more about these instruments. What else can they do?
Oh, one of the coolest things we've got on board is ice-penetrating radar. It's like, imagine sending sound waves through Europa's icy shell. We can use those echoes to actually map the ocean underneath.
Wow, so we could be talking about creating a 3D map of an alien ocean floor. And all from space. Is that what you're saying?
That's exactly what I'm saying. We're talking about potentially finding underwater volcanoes, canyons, maybe even
Hydrothermal vents? Like the ones we find on Earth?
exactly, hydrothermal vents. And those are particularly exciting.
Why is that?
Because on Earth, those deep-sea vents, they're teeming with life, even without sunlight. They're like little oases powered by the heat and energy from the Earth's core.
Okay, so if we find these vents on Europa and on Earth, those vents equal life. That's kind of a big deal then, right?
It's a huge deal. It would mean that Europa's ocean isn't just some static body of water. It means there could be an energy source down there, something capable of supporting life.
This is blowing my mind. But let's talk about the spacecraft itself for a minute. We've got this intricate cosmic dance planned, all these incredibly sensitive instruments. It must have taken a seriously impressive piece of engineering to pull all this off, don't you think?
You're absolutely right. I mean, start with the propulsion system. Europa Clipper has 24 engines.
24 engines. That's more than my car. Why so many?
Well, you have to think of it like this. Jupiter's gravity. It's like a cosmic whirlpool. So Europa Clipper needs those engines not only to reach its destination, but also to constantly adjust its trajectory.
Oh,
It has to actively avoid getting pulled in.
it's like a high-stakes game of cosmic dodgeball up there. And what about all those delicate instruments? We talked about that intense radiation earlier. What's stopping them from getting fried?
Good point. That's where the radiation vault comes in. It's basically this lead-lined bunker protecting the spacecraft's brain, so the computers, the flight software, all the vital stuff.
So we've got the brains protected, the engines all fired up. But what's powering all of this? It's a long way to the nearest outlet.
You're telling me.
Yeah,
But that's where those massive solar arrays we talked about come in. Remember those giant wings?
right.
We're talking about panels that span over 100 feet. They had to be meticulously designed to capture every photon of sunlight, even way out near Jupiter.
Wow. Talk about a long-distance relationship. So we're capturing sunlight, powering this incredibly complex spacecraft. But what about the data? Those precious glimpses of Europa, that information has to travel billions of miles back to Earth. How do we even begin to send information across such a vast distance?
Well, that's where Europa Clipper's secret weapon comes in. Its massive high-gain antenna. This thing is over 10 feet in diameter, bigger than a satellite dish.
Bigger than my living room. Seriously, that's one powerful Wi-Fi signal. So what happens when that data finally reaches Earth? Who's analyzing all of it?
Teams of scientists all over the world are eagerly awaiting every bite of information. They'll be looking at the images, the radar readings, the chemical analyses, piecing together this puzzle of Europa bit by bit.
That's amazing. A global team effort to unlock the secrets of an alien world. But with all that data, with all those possibilities, what are we really hoping to find? What are the big questions driving this mission? So we're talking about piecing together clues from an alien ocean billions of miles away. But it really all comes down to this. Is there life on Europa? Are we alone in the universe? What are we really hoping to find out there?
The age-old question, isn't it? And while we can't rule out more complex life, honestly, the real game changer would be finding even microbial life.
Really? What makes microbial life so important? Why is that such a big deal?
Think about it. Finding even the simplest life forms on Europa, that would completely change our understanding of life itself. It would mean that life isn't some fluke, not just a one-time thing that happened to happen here on Earth. It would mean the universe could be teeming with life in all sorts of incredible places.
Wow, gives you chills just thinking about it. But then what if? What if we don't find anything? What if there's no evidence of life at all? Does that mean the mission was a failure? Absolutely not. Even if we don't find direct evidence of life, Europa Clipper, it's going to give us so much information, invaluable data about Europa's history, its ocean, its potential for habitability. We'll learn about the ice, the chemistry, the ocean, what's happening on the ocean floor. That knowledge in itself, it's groundbreaking.
So it's more about the exploration itself, about taking that deep dive into the unknown.
Exactly. It's about pushing the boundaries of what we know. And who knows, right? Maybe Europa Clipper will reveal even more mysteries out there, things we haven't even begun to imagine.
It's like we're on the verge of a whole new era of exploration. And it all starts with this incredible mission, a daring plan, and a whole lot of curiosity.
Curiosity is what drives us, isn't it? That desire to explore, to understand.
Absolutely. And on that note, we'll leave you with this. What do you think we'll find on Europa? A vast, silent ocean, hydrothermal vents just teeming with life, or something even more incredible, something beyond our wildest dreams? Keep those questions in mind as we continue to explore the universe and all its wonders. Until next time, stay curious.